Welcome to clickmyproject.com.
Now we discuss about QR images, optimized image embedding in QR codes. Quick response code or QR code have rapidly emerged as a widely used inventory tracking and identification method in transport, manufacturing and result industries. Their popularity is due to the proliferation of smartphones capable of decoding and accessing one line resource, as well as its high storage capacity and speed of decoding. QR codes are used in variety of applications such as accessing websites, download personal card information, post information to social network, initiate phone calls, reproduce video or open text document. An important problem of QR code is it is impact on the aesthetics of publicity design. The square shape and limited color tolerance severely impedes the integration into billboard design or printed materials. This challenge is generated great interest for algorithms capable of embedding QR codes into images without losing decoding robustness. There have been several efforts to improve the appearance of such embedding, which can be classified into two category methods that modify illumination or color of image pixel, and methods that replace QR code modules. This paper introduced the concept of QR images, an automatic method to embed QR codes into color images with bounded probability of detection error. These embeddings are compatible with standard decoding application and can be applied to any color image with full area coverage. The QR information bits are encoded into the illumination values of the image, taking advantage of the immunity of QR readers against local illumination distributions. To mitigate the visual distortion of the QR images, the algorithm utilizes softening mask for the selection of modified pixels and non-linear programming techniques to locally optimize illumination level. A traceable method for the probability of error is developed and models of the optimizes the illumination levels of the QR images. To minimize the processing time, the optimization technique proposed to consider to be a amiably for parallel implementations. Experiments show the graceful of the decodation of the decoding rate and the reachable quality as a function the embedding parameters. Image processing is any form of signal processing for which the input is on a image such as a photograph or video frame. Most image processing techniques involve treating the images as a two-dimensional signal and applying standard signal processing technique to it. Quick response code is like a two-dimensional barcode, but the barcode readable by the optical machine. It contains which item is attached to the QR code, encode the details of numeric, alphabetic, bytes and binary. It gives more information about anything. It read by the imaging device only. The algorithm utilizes mask for the selection of modified pixel and non-linear programming technique to locally optimize the readiness level. Now we discuss about the flow diagram for our process. It is the flow diagram for our process. Here we load the color image. If the color image will be give, it is converted to the gray image. After convert the gray image, then we find the gray thresh and we done the binarization. After the binarization, the image will be getting the best value. This helps to select the pixel for QR code embedding, and then we will do the initial parameter for the GA with manual, and the GA will be select the pixel by using the binarization image and will choose the pixel from the color image, and the selected the pixel. After the selected pixel, the QR code will be embedding based on the selected pixel. The QR code will be generated based on the online source of normal QR code generator. After the QR code generated, that QR code embedding in the selected pixel. If the QR code embed in selected pixel, then it will be go to the embedded process. After the embedding, the QR code embed in the color image, and it is a result of embedding QR code color image. Then we retrieve the QR code from the embedded image, and then we analyze the normal QR code to it will be decode the message and be visible the decoded image. Now we see the demo of our process. Open the MATLAB source code and then right click the main.m from the MATLAB coding and then run the file for run the coding. After run the coding, the input process guide will be open. In this process guide, first we load the input color image from clicking the image button and choose any image from the database. Then we choose the QR code from the input image and choose any type of QR code here. Then that QR code will be generated based on normal QR code tools getting from the online source. Now we generate the mask for input image based on the QR code image. Here the input image will be converted to gray and then binarization after the image, and then it will be get the masking for based on the QR code. After the masking, we will extract the windows of input image and also the QR code image. Then it is the window extraction for input image and it is the QR code image. The windows extraction will be the page separation of each image. Here the input image and also the QR code will be separated the pages at 8x8 matrix. Here it will be giving to the optimization algorithm. It will choose the pixel from the image based on the QR code, and that QR code pixel will be replaced by that selected pixel, and the QR code will be embedded in the color image. Here the Windows extraction pixel will be shown. After the Windows extraction, then we go to the next for embedding the process. After the embedding process, first we optimize the pixel for the choosing the pixel for embedding the QR code. Then we go into optimization process by using the GUI algorithm. The GUI algorithm will be optimized the Windows extraction pixel, and then it will be choose which pixel will be for choosing for the embedding the QR code, and that will be based on the input image mask and also the input image Windows extraction pixel and the QR code extraction pixel. Here the GA algorithm will be initializing the parameter. After initializing, the GA will be optimize the pixel. Here the GA will optimize the pixel and it will generate the different type of choosing pixel, and that will be embedding the QR code in different types of manner, and it is the pixel and generation for selecting pixel. It is the GA output graph for the choosing pixel. Now the pixel will be choosing, then we embedding the QR code in the pixel, and it is the embedding QR code image, and it is the preview of embedding QR code image. Here the QR code will be embedded in the color image. Now we decode now the MLC value is 0.9. It will be source, our input process will be getting the better result, and then we go to the decoding the process. It is our original QR code. Now the QR code will be recognized with the normal tool. It will give the output for the process. Now click the home for take the another image, or else exit to exit the process.